attached when the alcohol is attached to this an sp2 carbon directly, that's when it's vinylic.
Okay. So let's suppose a phenol. So phenol is a allylic alcohol or vinylic alcohol?
Phenol, it's gonna be
Hmm?
vinylic.
Yes. Good.
Wait, sorry, I'm gonna be
And then we
honest with you.
discuss method of preparations.
Sorry.
Okay. Mm-hmm.
Wait, sorry, I wanted to
Yeah,
say something. I wanted to be honest, like I think I'm
yeah.
really struggling with these reactions. Like, or yeah, I don't know.
Yeah.
Like I don't think it's
Because
coming to
I
me as
think you,
easily.
yes, you need a lot of practice. In the mechanism, majorly the mechanism is a little bit harder to understand. Okay. That's why. I think, but in the alcohol, there is only these two reactions: oxymercuration, demercuration, and hydroboration oxidation. These two reactions are a little bit tougher mechanism. So that's why I told you that we doesn't need to study them, because I don't think so that you like for now you are able to catch all these mechanism, because because it's like starting point of yours, starting points of classes. So this is little bit harder getting these two mechanisms. So you can leave them for now. But like after, when your exams will come, and if these two reactions are in your syllabus, so in that case we will discuss them again. Okay.
Yeah.
For now you can leave them. You only needs to know that if these sort of reagents are coming, so in that case what type of product will form. Okay, like
Mm.
the product will form by the Markovnikov rule or anti-Markovnikov rule. That's the two major thing you needs to know. Okay. And you can easily answer the questions with the help of these rules. Okay. But the first reaction, hydration reactions, I think that is easier side, so you can do that reaction.
Mm-hmm.
So hydration reactions
Yeah.
need rearrangement only. Yes. So don't you need to stress out about these two reactions. Okay. And except these two reactions, do you have any problem in anything? Then you can ask me.
Um,
Hmm?
oh, I was gonna say, I think,
What is that?
huh?
Hmm? Tell me.
No, I was gonna say like, um, with regards to the homeworks, I remember you gave me two tasks, right, to search out or to revise hydrogenation oxidation, and then I think
Yes.
research
Hmm.
about carbonyl groups. I don't think I researched about. I think I forgot about that, but I did go over the
Okay.
mechanism of hydroboration oxidation again. But yeah, it's like kind of going over my head, to be honest with you. So. I think I just need to like go over the mechanism again and again. Um,
Okay.
yeah, but sorry, like to interject, but to answer your question, I don't think there's anything in particular I'm struggling with. It's just like the mechanism, obviously, but and I understand like Markovnikov, I understand anti-Markovnikov. I don't remember the reagents of the reactions. That's probably something I should look into and like revise that or memorize that. Um, and I understand alkyl shift, hydride shift. That's like a little easier for me to understand. Um, with ring expansion, I think I just need to look over that again. But
Mhm.
I mean, it's just like alkyl. It's just an alkyl shift, right? Either it's alkyl or hydride shift, and then deprotonation, or
Yes.
protonation, alkyl shift, or hydride shift, and then deprotonation.
Protonation, then if needed, then any sort of rearrangement or any sort of shift
Mm-hmm.
will be proceed. And after that, attack of nucleophile, that is H2, then in the last step deprotonation.
Mm-hmm.
Okay. Okay. So now there is Like we are discussing method of preparation of alcohol now. So there
Mm-hmm.
is two reaction left. The first we discussed only one reaction, only like one method of preparation we discussed up to now, that is from alkene only. First
Mm-hmm.
we discussed that is like from alkene. We discussed in like previously. There is three methods to form alcohol from alkene. Okay, alkene to alcohol. What is those three methods? The first is hydration. Yes or no?
Mm-hmm.
Then second,
There's oxymeration, right? Demercuration.
oxymercuration, demercuration. And the last one is
Hydroboration oxidation.
great. So in hydration, what sort of reagents we are using?
Um, H plus, right? And then H2O.
Yeah, H plus and H2O. Great. And in case of oxymercuration, demercuration,
I don't remember the name. It's like mercury and then OAC minus, right? Something like that.
OAC twice. Yeah. And
Oh, twice. Sorry, not minus.
and
THF?
THF.
No,
Good. Yeah. THF. Then
and then BH4, right?
no.
Oh, that's for sorry, that's for this
Hydrogenation.
last one.
Yeah.
Yeah.
So for this one, tell me.
I
HGO,
think there's peroxide. There one is peroxide, I remember.
H2O2 and
Oh wait. I thought that was for hydroboration oxidation. Oh,
yes.
is it for both?
No.
Wait,
Here is only H2O will come. And
H2O.
and one more thing.
Hey, which one are you asking about? B or C?
B.
B. Okay.
Oxymercuration, demercuration. See here. HGOAC twice, THF, H2O, and in the last
Oh, I
hydration.
said BH4. It's NaBH4. Sorry, yeah. Sodium borate, right? Sodium
Sodium
borohydride.
borohydride. Yeah.
Borohydride, yeah.
Sodium borohydride. Okay. Then in hydroboration oxidation, it's BH3
Mhm.
and
THF, right?
THF, yes, and
Peroxide.
peroxide. Peroxide in basic medium, OH minus. Okay. Okay. So these three reaction we discussed. In hydration, what we needs to know? What like the major thing which we needs to know in the product part, that carbocation will form, and if possible, then we proceed with rearrangement. In oxymercuration, demercuration, how we identify the product in oxymercuration, demercuration? Tell me. Via which
Hyd
law? Markovnikov or anti-Markovnikov?
Markovnikov.
Yeah. And in case of hydroboration,
Anti-Markov.
anti. Okay. Then now we start with the second reaction, that is from carbonyl. Second reaction is from carbonyl. So first you needs to know what is carbonyl. Do you know what is carbonyl? Anything?
C double O.
Yeah. Do you know the concept of electronegativity?
Mm-hmm.
What is electronegativity?
Electronegativity, I think, is the ability for an element or something to attract or an atom to attract electrons towards itself.
Yes. And is there any sort of a charge will occur if there is more electronegative element present? So let's suppose this is carbon
Yes.
and is double bond O. So in any compound, if C double bond O will come, so that compound is this compound is known as carbonyl group. Okay, C double bond O. In this case, first you tell me that hybridization of this carbon. What is the hybridization for this carbon?
The hybridization for the carbon sp2, right?
Great. sp2. sp2 hybridization. And how many sigma bonds are here?
3.
Three. And pi bond?
5 bonds, 1, right?
One. Great. And how many lone pair?
2 around oxygen,
Two.
right?
Yeah, good.
Yeah.
Two. And which element in carbon and oxygen is like more electronegative
Which
among carbon?
element? I think oxygen, right?
Absolutely. Oxygen is more negative, more electronegative. So if element is more electronegative, then in that case, it attracts electron or lose
Attracts
electron.
electrons, yes.
Yes. So more electronegative means it attracts electron. So it's attract electrons. If it attracts electrons, then in that case, don't you think that it gains some sort of partial negative charge?
Yeah.
Okay, gain partial negative charge. This sign S or delta type sign represent partial. Okay,
Mm-hmm.
do you know this?
Yes, delta.
This about this one. Okay, delta. So whenever there is a partial charge, so we will represent that partial charge with delta and negative. So partial negative. If oxygen is more electronegative, it attracts electrons, so it gain partial negative charge. Same as oxygen, there is carbon also. Carbon is less electronegative, so it lose electron. Yes or no?
Mm-hmm.
If it lose electron, then it gain partial positive charge. Yes or no?
Mm-hmm.
Okay, great. So if see the partial negative charge will come, so partial and it will have like partial positive charge. So it work as electrophile or nucleophile. Carbon
Carbon would be a nucleophile, right?
working as nucleophile or electrophile. Carbon having partial positive charge. So positive charge means
Then that would be, sorry, that would be electrophile.
yeah. So it behave as electrophile. Electrophile. Okay. And oxygen behave as nucleophile. Yes or no?
Nucleophile. Mm-hmm.
Great. So this is the basic thing about carbonyl up to now. Okay. Now we start with the reaction, like what sort of reaction we can proceed with the carbonyl. Okay. So from carbonyl, there is two types of reactions. The first is with Grignard reagent, and the another is like with the use of reducing agents. Okay. So from carbonyl, we will discuss two type of reactions. Wait a second.
Wait, sorry, can I take notes on what you've already written, or do you want me to wait?
You can take screenshot for this, or you want to
Oh,
note down. If you
yeah,
want to note down, you can note down this. Okay, okay. So
yeah, I
you take
remember
this.
I would take screenshots, but then like I would have to rewrite it again. It was just kind of a waste of energy, you know? Took up a lot of energy.
Okay.
Okay, wait, sorry, I should have stopped you earlier too, so it was my bad. I have stopped you from carbonyl to alcohol. Um, then okay, well, Double O. More negativity means outcome. Mm, Wait, sorry. Less than after negative means no. Yeah. Positive electrons means gains. So this behaves. With Grignard reaction. With Grignard reaction. Okay.
Okay.
What
Now,
about the
as
stuff? Sorry. What about the stuff before this? Should I copy? Maybe I could do that later. Yeah, continue.
before, no, we didn't discuss anything up before that. This is the
Oh,
this is the past reaction which we discussed in the class. Okay. Okay, so we discuss firstly that how we can prepare alcohol from alkene. So in that case, we discuss three reactions. Yes or no? These three
hmm.
reactions. Yeah. But now we discuss alcohol from alkene. So in that case, we discuss two reactions again. Okay. The first reaction with Grignard reagent and another is with reducing agents. Okay.
Okay.
Yeah. So firstly, you tell me what is Grignard reagent? Do you know about anything?
Grignard reagent. It's okay. So there's reducing reagent, right? So then Grignard is gonna be the adding reagent.
No, no, no. Grignard is a different type of reagent. It is like
Okay.
it represented by R, Mg,
Okay.
X. This is the Grignard reagent. Okay.
Mm-hmm.
And in case of R, Mg, X, this R is partially negative charge and Mg, X is partially positive charge. Okay.
Mm-hmm.
And reducing agents, there is some examples of reducing agent. Did you know about NaBH4, which we discussed
Mm-hmm.
earlier?
Mm-hmm.
What NaBH4 will do?
Mm, reduce means to make it like more like less acidic or
No.
more acidic. I'm not sure then.
NaBH4 used to donate H minus ion, if you remember.
Oh, okay.
Reducing, what is reducing agent?
Mm-hmm.
Reducing agent donates hydride ion. Okay,
Mm-hmm.
H minus ion. You note down this thing that reducing agent donates H minus ion, hydride ion.
Okay.
Okay.
Yeah.
Okay. So now let's start with the first. Okay, so one more thing that as a reducing agent donate H minus ion. So Grignard region in Grignard region, how the bond will break in between R and MgX. So R having negative charge and MgX having positive charge. These two things which you needs to know. Okay. Okay.
Wait. Sorry. Wait, can you repeat that again?
That Grignard reagent donates R negative. R is a alkyl group. Okay.
Okay.
And reducing agent like NaBH4 and LiAlH4 donates H minus hydride ion.
H minus. Yeah.
Okay. Okay, so now we will start with the first reaction that is from Grignard reagent. Okay, so the first one we going to start. Grignard reagent. Okay, so let's suppose firstly what I need to take a carbonyl group. Okay, any carbonyl group. So let's suppose I'm taking CS3, C double bond O, and CH3. This is a carbonyl group. Yes or no?
Mm-hmm.
Hmm. And do you know what sort of functional group it is?
Well, there's aldehyde and ketone, right? So I think this one is
Yeah.
ketone.
Yes, very good. This is ketone. And what about this?
Which one? Oh, that's
The second.
carboxylic acid, right?
No,
No,
this
it's
is
not. Sorry. That's not carboxylic acid. Oh. Oh
it's
yeah,
L.
aldehyde is towards the end of the chain.
Yeah, and this is the ketone. Okay. So whenever we are using Grignard reagent, what is Grignard reagent? RMGX. Okay. RMGX. In this case, I also take RMGX. So as I told you that RMGX converting into R, positive or negative?
Negative, right?
Negative plus MgX positive. Okay. Now in ketone, in this group, this carbon is positively charged or negatively charged?
Positive.
Positive. And the oxygen?
Negative.
Negative. So tell me, this R, if the R negative attacks to this carbon, okay, and this
Mhm.
bond shifts to this side. So what will be the product in this case? CS3, CO minus, and here is R attached, okay, and this will be CS3. Done.
Mhm.
And this MgX is positively charged, yes or no?
Mhm.
So here MgX will attach, that is positive. Any doubt? RMGX break into two type of molecules. The first is R negative, second is MgX positive. R negative is an alkyl group that is negatively charged. MgX that is magnesium halide that is positively charged. Okay. After that, this R negative attack on carbon. Why only on carbon? Because this carbon is partially positive charged and this R is negatively charged. So it will attack on the carbon, and when it attacked to the carbon, this double bond shifts to the side where oxygen present. Okay. So oxygen is gaining negative charge. So after this negative and there is remaining MgX positive will be there here. So it MgX attached to the oxygen which is negatively charged. Okay. Any doubt up to now? Hmm?
Mm, no, sorry, let me double check now. I'm gonna see if I can follow along.
Okay, so let first this step also like this is the last step. Then you check. Okay, now we are using H2O. Okay, H2O is a hydrolysis process. Hydrolysis means there is one term which we are using before this reaction, that is hydration. What is the meaning of hydration?
Adding
Mhm.
water, right?
Addition of water. That is
Yeah,
hydration.
adding water.
Yes. And what is hydrolysis? Hydrolysis means break a bond and
Extracting water, yeah.
yeah. No, not extracting, like we need to break a bond and add hydrogen to
Oh,
that. Okay. So in this case, this the bond between OMGX will break, okay, and
Mhm.
one H will attach to it. Okay, so what will be the product in that case? It will converting into CH3, COH, CH3. Okay, this is the product. Hmm. Now you see. Now you check this one. Any doubt? If you have any doubt, then ask.
So what, sorry, where are you adding the hydrogen?
To the oxygen. See, O minus MgX bond
Oh,
will
okay.
break and hydrogen attached.
Mm-hmm. Okay.
Any doubt?
Mm, no.
Sure. Okay. So,
Wait, what's the MGX again?
mhm,
What does MGX mean again?
MgX is magnesium halide,
Oh,
and this part is known as adduct. Okay.
oh, okay.
Okay. Hmm. Now you start with the second one with aldehyde. Okay. Let's start with this one.
Wait, sorry, what do you want me to do?
To form this, to form the product from aldehyde.
Okay.
And I'm writing CS3, C double bond O, H. Okay. And R NGX. Now you start with this. Done?
Wait, 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 wait. Is the main difference gonna be the hydrolysis step or
You only needs to do the same reaction as we discussed for ketone.
okay, I was just wondering because of the H.
You don't need to stress about H. You directly put the RMGX. Okay.
Okay.
Huh? Hmm.
Yeah, so
So how the reaction will proceed? RMGX break into.
R minus.
Okay. Now R minus attacked at carbon. This bond will shift over here. It will converting into CS3C O minus. Here is hydrogen. Here is R, and one mgx will going to attach here. Okay. Then hydrolysis will take place, H2O. Then CS3CHR OH will be attached. What sort of issue you are facing in this? This is so easy.
But I'm learning it for
Hmm?
the first time. It's easy for you.
No, like I just described whole mechanism before this one, and the mechanism is written over here.
Yeah. No, I was gonna follow that. I was just wondering if the hydrolysis step is different because of the hydrogen. Never mind, I was overthinking. It's fine. Yeah, it's the same thing.
Mhm.
The only difference is the hydrogen at the end, right? It's not like it's affected. The hydrolysis doesn't affect the
If
OH.
there is a OH instead of hydrogen, then in that case, that will affect.
Oh, okay. And in this case, the hydrogen, the water gives the
Let's
hydrogen, right?
suppose, okay, let's start with that. Okay, but that will be a little bit different. Okay. Okay. So we can go with only these two, aldehyde and ketone. Okay. So what is the difference if I start with ketone and with aldehyde? What is the major difference between them?
Ketone and aldehyde, the main difference, like in any ketone is in the middle of the molecule, right?
No, no, I'm asking about the product. Like, what is the difference in product?
Maybe the configuration, or like the only difference is the CH3 group versus the H group on the right side, right?
So can I say that if I use ketone, I am getting a tertiary alcohol.
Yeah, the configuration or the
And in case of aldehyde, I'm getting secondary alcohol. Okay. So now, if examiner will ask you that can we prepare primary alcohol with the help of Grignard reagent? So how you will answer that? If I
primary
need,
alcohol.
yeah, primary alcohol from Grignard reagent.
I think the oh secondary. Let's see. I think the carbonyl group would probably.
What I needs to prepare? I needs to prepare primary alcohol. So how we can prepare primary alcohol? This is your homework, okay? I'm writing here your
Okay.
homework. Okay, note
Wait,
down up
so
to now.
that,
Mhm.
the homework, me prepare primary alcohol with carbonyl group. Does it have to do with the double bonded O, right? It's all about that, right? Or the positioning of the carbon. Wait, is it the positioning of the carbon?
Position of carbon. How?
No, in the ketone versus aldehyde. Or I don't know, there's some rearrangement of the atoms, right?
Yeah, you can think about that. Okay. Okay. So after that, after this Grignard reagent, what is the next part? Here is in carbonyl. Hmm?
The next part,
Mm-hmm. After Grignard reagent,
as you're reducing, right?
yeah, second part will be with the reducing agent. So
Okay.
before going to start about reducing, like with reducing agent, you needs to know what is reducing agents are.
Wait, sorry, give me one second.
Reducing,
Give me one second, I'm
okay.
coming back. Okay, I'm back.
Okay. So what is reducing agent? Reducing agents are used to donate H minus. Okay, hydride ion. They
Mm-hmm.
donate H minus ion. Okay.
Mm-hmm.
Okay. So let's suppose we start with the first reducing agent, that is uh, H2 in palladium. Okay. H2 and palladium. This is the first reducing agent we are going to use. Okay. So
Okay.
we are discussing that how we can convert carbonyl compounds to the alcohol. Yes or no?
Mm-hmm.
Yeah. So what I'm taking firstly a carbonyl compound. Okay. And now I needs to convert this carbonyl compound into alcohol.
Mm-hmm.
Alcohol. So here is oxygen, and I need to attach one hydrogen over here and one hydrogen over here. Yes or no?
Mm-hmm.
So what a reducing agent will do, they will attach H2. They'll attach to this H2, wait, to this H2 over this double bond. Okay. So one hydrogen to this oxygen and one hydrogen to the carbon. Okay. So that's how H2 palladium will work.
Mm-hmm.
What H2 palladium will do? This will add two hydrogen to this carbonyl group. Okay.
Okay.
Any doubt?
No.
Hmm? No. So as H2 palladium, there is two groups more. The first is NaBH4. Okay. And the second
Okay.
is, sorry, third is LiAlH4. Okay. So now, see in this case H2. H2 means there is how many hydrogens? Two hydrogens. Yes or no?
Mm-hmm. Yeah.
In case of NaBH4, we are having how many hydrogens? Four hydrogens.
Mm-hmm.
Okay. And in case of LiAlH4, we are also having four hydrogens. This is known as sodium borohydrate. Sodium borohydride. And this is lithium, aluminium hydride. Okay. So this lithium aluminum hydride is more powerful and more expensive as compared to sodium borohydride. So if examiner asks you that if you are having two choice, that one is lithium aluminum hydride and another is sodium borohydride, which you will choose?
Lithium.
Lithium. Why? Because it is more powerful. And if the budget is a little bit tight, so in that case, we're going to use sodium borohydride. Okay.
Okay.
And all of these are working as a reducing agent. What is the meaning of reducing agent? The reducing agent is used to attach hydrogen to any double bond. Okay.
Mm-hmm.
Hydrogens, addition of hydrogens to any double bond. If let's suppose I am using alkene instead of carbonyl compound, so in that case, what will be the product?
If you're
Tell me.
using a alkene
Yeah.
instead of a carbonyl,
Instead.
um, it would
Mhm.
just be like it would just be substituted across each double bond rate or something like that.
Hmm?
It would attach to each double bond or something.
So hydrogen will attach to a double bond. That's the only thing.
Yeah.
Okay. Great. So this is all the reactions up to now which we discussed is method of preparation of alcohol. Okay. How many part we discussed in method of preparation? Hmm?
Method of preparation. Reducing, and then what was the other one? Grignard.
Grignard. Yeah.
Grignard. Okay.
How many total reaction we discussed up to now?
Like from this past week or
Yeah, like from the starting of alcohol.
I think there was from the starting of alcohol, like from today, or like
No,
what?
like when we start alcohol.
So there was like hydration, and then there was like oxidation, hydration, oxidation, then no, hydration? No, just hydration, right? And then oxymercuration, demercuration. And then hydroboration oxidation, right?
Okay, so first we start. Let's okay. So we'll start with okay. So in case of alcohol, when we start alcohol,
Mm-hmm.
okay. Firstly, we discuss about classification of alcohol. Yes or no?
Mm-hmm.
So a classification in classification we discuss three type of classification of alcohol. Can you tell me on what basis we discuss that three classification?
I mean, there's degrees of carbon, right? Or degree of alcohol, which is based on degree of carbon.
Yes, yes. And
The number of alcohol groups
number of
present in a
not number of
molecule.
alcohol groups, number of hydroxyl group. Okay.
Wait, we don't say alcohol? I'm confused.
No.
Oh.
This is known as hydroxyl group.
Oh,
Okay.
hydroxyl. I don't know why I kept saying alcohol. Okay, yeah.
Okay.
Then I think it's just yeah. And then how it's attached to the what kind of carbon it's attached to.
Mhm.
So like it could be allylic, vinylic, and then that influences the rate of reaction or how the reaction goes. The carbocation influences the rate of reaction.
Wait. So we are
Oh.
discussing only about classification. Okay. So classification and then allylic and vinyl liquid. And okay. Then after classification, we go with IUPAC nomenclature.
Mm-hmm.
Okay. So in IUPAC nomenclature, what is the three major rule? Mm-hmm.
IUPAC, the three main
Tell me.
rules is you have to name the longest chain and then identify the longest chain and then you if like the hydroxyl group is like let's say it's on the left side, right? So then you would start the naming from there. And then if there's other groups, you would also like mention that, and then you have to mention the carbon that those group the and what number of carbon those groups are on, how many of them there are, and then use the prefixes. So and then
Yeah.
if
Yeah.
and then yeah, and then use the suffixes for the hydroxyl
Mhm.
towards the end. So I think that's it, right?
Then we discuss method of preparation.
Method of preparation, yeah.
Means how we can prepare alcohol. Okay. So
Mm-hmm.
in that case, how many methods we will discuss? Two.
Mm-hmm.
So in these two method of preparation, firstly from tell
Firstly,
me.
the method. Hmm?
Uh-huh. Firstly from.
Method of preparation.
Hmm.
Mm, that's what we just discussed today, right? Or did we discuss something earlier?
Earlier also. Those three reaction.
Oh, do you want me to name the reactions?
No, I just want to know about reactant. So from alkene we discussed firstly in the
Mm-hmm.
last class. Then we discuss from carbonyl groups.
Mm.
Are you getting my point? Like how we discussing this?
Wait, so I don't understand your question. Are you asking me what reactants that you put in?
Yes, what sort of reactants we are using to prepare alcohol. So in first case we go with alkene, and in the second case we go with carbonyl group. So after alkene, there is three methods we discuss: A, B, C. Do you remember those? Hydration, oxymercuration,
Mm-hmm. Yeah, yeah,
demercuration,
yeah. Yeah. Hydration.
hydration. Then
Oxymercuration, demercuration, then hydroboration, oxidation.
yes. So in case of hydration, what is the reagents? Now, what is the reactant in this case? Alkene is the reactant. And what is the reagents we
Mm.
are using in hydration?
Reagents would be H plus, right?
Yeah.
And
And
then H2O.
yes, great. And in case of oxymercuration, demercuration,
Um, you have HGOAC2, and then you have THF,
hmm,
and then you have what is that? An NABH4.
H2 also there, no? H2
Okay, I
and then
I think we
NaBH4.
talked about it in the beginning of class. I don't think I remember every single thing, so I still need to memorize it properly, but
So you need to remember,
yeah.
that's why I'm revising all the things again and again, okay? So that is like,
Yeah,
yes. Then hydroboration
yeah, that's
oxidation.
good. Hydroboration oxidation. There's is there BH4 here? BH3, right? BH3.
Yes.
BH3. And then there's peroxide, and then there's uh OH minus?
Yeah, great. One more thing.
THF. Okay.
Okay, great. Then from carbonyl, we discuss two part. Okay. Can you tell me? The first is
Grignard.
very good. Grignard reagent.
Then reducing.
And absolutely very good. So that is reducing agents. Okay. So in case of Grignard reagents, what is the reagent? R minus
The
Mg. Hmm?
huh?
What is the reagent
Oh, you
in?
just wrote it. You didn't. I was gonna.
So it's RMGX. In that case, how they will break?
How will they break? So the R minus will attack the carbon, and then the double bonded O will fall off.
Yeah, the double bond or the electrons of the double bond shifts toward the oxygen.
Yeah.
Great. Then in reducing agent, what sort of agents we are using?
Reducing agent, there's, sorry, give me one second.
Mhm.
Lithium? No,
Yeah,
it's not reducing? Yeah.
lithium, aluminium hydrate, tetrahydrate, we can also say, and
Mm.
NaBH4.
Sodium borohydride, yeah.
Great. And then there is one more, that is H2 palladium.
Mm-hmm.
Hmm? Okay. So whenever there is a H2 palladium will be there, so that method is known as catalytic hydrogenation or catalytic reduction. Okay, you can write down here. So we can write down here. that whenever this H2 palladium will use, so this process, here you can write that this process, do you note down like this part?
Mm-hmm. Yeah.
Catalytic reduction. Okay,
Mm-hmm.
you can note down this. Any doubt up to now? Anything? Now I'm starts to giving you some questions. Okay.
Okay.
Note did you note down all the things which we discussed today? All the part?
Yeah,
Hmm?
except for the first part, you were just naming the reagents, right?
This one? You didn't
Or
need
actually,
this.
yeah, yeah,
Uh,
yeah.
because this is we already discussed.
Yeah, yeah.
So from alkene, from carbonyl, Grignard reagents, you can double cross check this part. Then I'm starting to giving you some questions. Okay. Anything which you left? Any part? No?
No, I'm
Okay.
good.
So now you can start with the questions. Start with me. Okay. So the first question is what you needs to know that I'm giving you some sort of statements, okay, some sort of reactions. So you needs to prepare the product and give the IUPAC name to the product. Okay. So you can start with the question. E. Catalytic reduction of butanol. If you can like if you will do these questions, that means you have a clear concept in this part. Okay. And if you are having any sort of problem, then you need to revise the things again and again.
Yeah.
So the first uh, in this first catalytic reduction of butanol, so you needs to proceed catalytic reduction of butanol, and what will be the product in that case you obtain? You needs to give the IUPAC name of that particular product. Okay.
Okay.
Hydration of tropine in the presence of dilute. So I'm giving you questions from like the starting of alcohol. So it can be like anything from alcohol. Okay. This is not from only today's class. This is like from whole alcohol which we discussed.
Okay.
Any doubt?
Sorry, ma'am, I'm still writing them down. Okay, I wrote these down. So now what do you want me to do? You want me to solve them?
Yeah. So the first one you can like do for now, and second and third is your homework, B and C.
My homework?
Yeah. So there is total three questions in your homework, the B and C, and the first one that is how we can prepare primary alcohol from Grignard reagent. Okay, so for now you can start with catalytic reduction of butanol. How we can solve the first one. Okay, so you only going to approach the questions.
Sorry, what did you say
Okay,
again, ma'am? How we can prepare what?
how you'll approach this question, the A question.
Oh,
Yeah. So,
the A question?
yeah.
Okay. Oh, you want me to do that now? Sorry, I thought you said something else. Okay. Catalytic reaction of butanol. Let's see.
Hmm? How we can approach that question?
Um, Catalytic reduction. Okay, so for catalytic reduction, there's two. Okay, reduction means that we would have to use a reducing reagent. So
Hmm.
there's a few different types, right? So there's sodium borohydride, and then what's the other one? Lithium.
What I
Um,
what is catalytic reduction? First, you tell me.
oh, catalytic reduction. Is it the one with palladium?
Yeah, high H2 palladium. And what is butanol?
H2. Hmm?
What is butanol?
Nail or null? I think I wrote
Nail.
down null.
A-L.
Oh. I think is it a carbonyl
Yeah. So in
for the
carbonyl, is it a ketone or aldehyde?
butanol?
Yeah.
Uh, oh, I don't know why I was drawing a ring structure. Okay, that's like totally wrong. Butanol. Okay, catalytic reduction of butanol. I think the carbonyl. Where would the carbonyl be? I don't know.
No, I'm
Oh,
asking you. Yeah.
sorry. What you were asking me if it's an aldehyde or
What is
ketone?
butanol? What is the structure of butanol?
There's four carbons, right?
Yeah. And what is functional group here?
I think it's a carbonyl.
Carbonyl, yes. But what carbonyl? Like carbonyl can be aldehyde, acid,
Mm-hmm.
ketone, any ester, anything.
Mm, maybe it's like I'm not sure. Aldehyde or ketone,
Al,
right? Probably
Al shows aldehyde.
aldehyde, yeah.
And if it is a butanone, In that case, it will be ketone. Okay.
Oh,
Butane. So in that case, it will be ketone. It's aldehyde. So at which position I needs to attach carbonyl?
carbonyl group, you would have to attach it towards the end, right?
Yeah. So here, is it right or not?
Yeah.
Sure.
Mm-hmm.
Okay. So after this butanol, what I needs to do, I needs a catalytic reduction. So what is catalytic
Mm-hmm.
reduction?
It happens through palladium, so the hydrogen attaches to the double bond alkene.
So
Or
what
no,
will be the
sorry, not the
product in?
alkene. Sorry. Huh?
Mm-hmm. Uh-huh. Tell me.
The C double O group, it attaches there.
So can I write this mm, like this? Is this right?
Mm-hmm.
Sure.
Mm-hmm.
So what is the IUPAC name of the product here?
The IUPC APC name. So it's a four-membered butanol, right? So then it would be um one, two, wait, one, two, three, four. Oh, four. Yeah, so butane. So there's a, I guess if you number the carbon starting from the carbonyl group, like where that carbon, then it would be like for there would be an aldehyde on the first carbon. So there would be butane one al
All.
all.
Yeah.
Oh,
So you
because
can
of the
write butanol and you can also write here butane one all.
wait,
Okay.
didn't you say that it's an al butanal, or is that something different?
And yeah, butanal. This one is butanal because this is aldehyde group here. And in this case, OH means alcohol group. So here we are using OL.
Oh, I
Okay.
was looking at the first structure. Sorry, that's why I was confused. Sorry.
Yeah.
The first Wait, the first group is an aldehyde, right?
Hmm.
And the first structure or the reactant, and then oh, okay, and then after just an hydroxyl group.
Yes. Okay.
But I had the right idea. It's just the suffix
Yeah.
is wrong.
Yes.
Yeah.
Yes. And you also
So,
remember catalytic reduction.
huh?
You also know what is catalytic reduction at the time when I asked.
Yeah, because I actually encountered this reaction before too, so I remember some things about it, like palladium. I remember having to go through that reaction before.
Hmm. Okay. So the after that we discuss chemical properties from next class. Okay, chemical properties of alcohol.
Chemical properties of alcohol.
Yes, that is the last
Um,
part in alcohol. And but we
last
need
one.
like 2 or 3 classes for that because the chemical properties of alcohol is little bit larger as compared to these reactions.
Oh wait, ma'am. I was gonna say I think I forgot. I think sir didn't send me the homework questions. I forgot to ask him. I think I was supposed to ask him. Should I do the ones you already assigned to me? Remember
Which one?
from last class? The ones on the mechanisms, right? Or like hydroboration, like predicting the
Yeah,
products.
you can ask. So do you have any doubt in that reaction? Hmm?
For hydro, I already mentioned. I think it's just really long. It's just complicated. I think I need to just like
Yeah.
go over it a few times. That's all.
Yes, yes, it's a little bit complicated. You need to like revise this part again and again. So after revisions, some sort of revisions, you are getting some pictures of these reactions. Okay. So by only revision you can get these.
Like a mental picture, like something in your
Yeah.
mind.
Yes.
Yeah, yeah,
Yes.
you need that.
Yes.
Um, what's it called? No,
You
remember
understood the approach, yeah, like how they will approach to each other.
mhm,
Yeah, that is the major thing.
the approach.
Yeah.
Wait, ma'am, sorry. With this, like on this topic, you give me some problems. Remember the IIT ones? Maybe I should just take a screenshot of that.
Sure.
Do you want me to do those?
We already did do these problems here. See? So in
Oh,
like
we already.
whenever you are giving answers, direct answers to the hydroboration, oxidation, and oxymercuration, demercuration, in that case, you doesn't need a mechanism. You only need to know that at which place the product is as Markovnikov and at which place the product is from anti-Markovnikov. Only that part you need to. So you can
Okay.
take screenshot of them, but
Okay, but do you
yeah,
think
we
it'll
discussed
still be
the
helpful
major
to
part.
do you think it'll
Like
still be helpful to do those problems though, ma'am? Because I didn't do them. I know you told me
mm,
to.
no, that like
No?
because no, because the major problems which you needed to understood, we already discussed that problems.
Okay.
Okay. And if you want, like after chemical properties, I'll give you some like 10 to 20 problems from the whole chapter. Okay. Because if you are going to do only one or two reactions and the solving problems of only one or two reactions, so in that case, you are not able to approach new questions. Okay. Let's suppose
Mm-hmm.
I gave you some gases from this, like from alkene to alcohol, and you know that there is only three reaction, and you can directly give the answer, like if the product
Yeah.
is anti-Markovnikov or Markovnikov or carbocation. So that is very
Mm-hmm.
easy, and I
Yeah.
think that is completely like wasting of our time. So when we complete the complete chapter, complete the alcohol part, so after that I'll give you some questions which is like preparation and
Mm.
chemical properties and structure of alcohol, IUPAC naming, like that.
Like
Okay.
the newer stuff that we just went over and stuff, like
Yes,
in
yes,
this class, right?
yes, yes, like this, these questions are also good. So in that in that part you are going with IUPAC name, you are going with method of preparation. Okay. B
Okay,
and C
so then
also, yeah,
what's my homework now?
this B and C part and the one which I gave you earlier in this class, and yeah, these three questions you can do, and yeah, from next class we'll start the chemical property. So that is, I don't think so that all
Wait,
the
wait,
things are
ma'am, sorry, wait. What did you want me to do for the homework?
this B and C question,
Oh, B and
and
C?
yeah, and then one more that I give you here. How we can prepare primary alcohol with carbonyl group.
Okay, B and C. Okay. Do you think I know I'm not really making as much progress as you probably are expecting because I know in the first chapter, like I made a lot of progress. Like I could answer every single question, like when you took my test. So hopefully I can still like I can make more progress on this,
Yes, yes, yes.
chapter.
Mm-hmm. You are doing
I think it'll just take some time because it's just
yes,
a little more
yes.
complicated. Yeah.
Yeah, this is complicated and this is the new part for
Hmm.
you. So you need to like digest firstly these things, after that you can approach new questions. Okay, so that's why I'm not giving you a lot of problems in first class. You can go through with these reactions, these mechanism firstly, then in next class we will discuss some more complicated problems. Okay, these are the like general reaction
Okay.
base.
Okay. So should I just revise these again?
Yes, yes, yes.
Everything?
Yes, you need to
Okay.
revise all the things and you need to like you try to remember all the things firstly. So like after these class you are, if suddenly I ask you anything, so you are prepared to that questions that yeah we discuss in that class. Okay, so
Okay.
yeah, in organic chemistry you needs to learn all the reagents, all the sort of thing. Like if see here today we'll start the Grignard reagent. So you need to know like how Grignard reagent will break, at which position Grignard reagent will attack, and how hydrolysis will process in that case. Okay.
Okay.
Yeah. Okay. So we'll meet in next class. Anything? Any doubt you have?
No, I just need to revise. That's all.
Okay. 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 Great.
Thank you, ma'am.
Bye.
Have a good rest of